All right. So we'll look at the remaining part of the internet today. And of course, we'll continue to learn about it in remaining 6-7 lectures on internet. Okay. These are the contents. Now, this is a quiz to you, the question to you, and that requires you to understand how URL that you use when you browse a website like HTTP or whatever, right? Look at this question. Which one was it that robbed you? You'll have to find it out. Now that means that URL can be very complicated, right? Okay, I mean if it's something like this, HTTPS www dot, some companies say, for example, IBM.com is very clear to you, right? Is this looks okay, but it could be some name, say XYZ dot some some dot com slash IBM something, right? Then you can be in doubt, whether this is correct or not. So now, before you click, look at the URL, and most of the time you can avoid going to a website which is a malicious website. Okay, so this cartoon or this quiz is about that, for you to figure out the what one of these is malicious, could be malicious, right? It is of course malicious here. You'll just figure it out what is that, and please go through this cartoon as well. All right, so last class we have looked at how packets traverse in the internet, and simple. So we visualize it this way. This is your laptop, and then there is a server. So you send a request, or when you want to browse a page, request goes from your end, and some exchanges happen, and then you visualize that the data is coming to you, like a page loads or whatever. You some animation starts or something like that, right? But in actual, this is a virtual world to you. Looks so simple, but actually the packets, whatever you are doing, converts into IP packets, and packets traverse over the physical network like this, which consists of large number of routers on in between. In general, your packet passes through many number of routers. Maybe it could be 10 or 15 or sometimes less. Okay, so this is the view that we have. Yeah. Okay, all right. So this is how packets traverse. Now all this is not visible to anybody, right? Okay. Or packets can traverse like this. Okay, all right. Now this is a picture that you are sending it to someone, right? Or someone is sending it to you. Okay, like I am sending it to you. Okay? This picture of Mona Lisa, beautiful picture. Okay, how does it go? Can it fit into one packet? Possibly not, depending on what is the resolution of this picture. But in general, we can say part of it can go in a packet. Okay, so let's assume these three parts have already gone. The fourth one now is to go, and one IP packet contain only one part of it, right? So now this part will come in IP packet. When IP packet is formed, then there will be destination address, which is IP destination address, and there will be source address, who's sending it, like your machine is sending it, your machine source address, and then it goes over the internet. Now note that what is used for routing is nothing but IP address is used for routing. Routing means the information at each node in the route. It looks at the destination IP address and then takes a decision where to go based on some table that router has. Okay, So this picture can actually go to other end, and that is you, and when you receive it you can recreate this picture depending on what is the format here. Use the same logic, the logic that was used to create this pic, to reassemble this pic back. And that's how this is called application logic, right? Whatever application you are running at this end, same application you'll have to write the other end to read or to play, whatever, right? Okay. Now note that internet is like a leaky pipe, and it may have holes. This is a hose pipe, right? It may have large number of holes. Okay, so your packet or fluid that you're sending may get lost. It may get duplicated. It may go somewhere else, right? So internet does not say that I will provide safe delivery of your packet to other end. It simply says I will try my best. If it reaches to other end, it's okay. Otherwise, it's not my job. And that's the beauty of internet, and right, because now it is left to end applications to take care of its applications requirement or its own requirements, right? So now the packets, now internet design, this is the internet. Okay, it does not say packets will reach always fine, so it may get damaged in between. It means that some bits can get garbled. Okay, internet in between is not going to check whether it is getting garbled or not, right? So for example, when your mom is sending you laddu packet, there's a possibility that some laddus may be missing in between, or something else may come instead of laddu. The courier service will not give any guarantee. Similarly, on internet, it does not give any guarantee that packet will not be damaged. Okay, so damaged packet may also be received here. Then what this receiver will do? It has to have logic, or it has to run protocol to find out is a garbled, is damaged. Now it has two choices then. Okay, that first is that it may just drop the packet and continue its job. The application here may not require higher level of reliability. A packet loss doesn't make much. For example, there is streaming of video picture, okay, a match or something like that, cricket match. There's a one packet is damaged, it's okay. Your router here will simply drop that rather than requesting to source to resend the packet. Now, of course, that can also be done. Sometimes most early protocols do that, but packets can always be dropped. Okay. Now, second thing that happens is that packet may arrive out of order. So here the first packet is started first, then the second packet. If you go back first, oh sorry. Okay, this is the packet generated. Okay, so okay, this was a damaged part. Now second packet now will reach first. Now what it can be done? If you play this packet first, assuming that you have a video player and play this packet first, second packet first, and first packet second, then picture may look damaged, right? Or it may be, or if there is a file being sent and you put second part of the file first, then the file is damaged, right? Or file is unusable. Like this pic here, monolith picture, if you just interchange the pieces, then it will not work. So it will not look at all like a normal picture, right? Okay. Now what may also happen is that routers may duplicate the packet. Same packet may get duplicated, right? So now what will happen if you are using video player or a file you are being sent, if you put two of these in the output, then the output may will be in error, right? So now whose responsibility is to find out that these are duplicated? Internet says that it's not my responsibility. It's not. If some node has created two packets instead of one, both will reach because both will be same, have same destination address and will come here. Okay, and this at the end node has to find this out. Okay, all right. Or packet may in between get dropped. Like here, if the buffer here is full, okay, this router will simply drop the packet. Now you cannot blame the internet for this dropping of packet. Internet will say it's none of my responsibility. So when you take, for example, internet connection, read the fine print, right? Do they give any guarantee? No. Okay. So now internet is, that's the reason we call it best effort network. It does not give any kind of guarantee. It doesn't even say that your packet will not reach to some other node. It doesn't say anything, right? So now the question is that, hello. Okay, the question is that how packets find their way across the internet, and answer we know by now, that there is IP address and each node on the way looks at this IP address, destination IP address, and then takes local decision to send it to appropriate route, right? Appropriate link. If suppose there are links here, there is one extra link here, like this is the network, then this router based on destination IP address, this router will take decision whether to send it on this link or the link here. That's called switching inside router. Overall routing requires a lot of local decisions in router based on some table they have. Okay, and simply when packet comes in, it will look at some entity here which is kind of destination address, some information based on destination address, and then take a decision whether to send the packet to one of the outgoing links. Okay, okay, all right. So IP address is, as we said, IPv4, this IPv4 address, which is 32 bits, and you can write it, put it in as a 4 groups, and these are the hex number. Okay, this 8, yeah, 8 bits. Each will have 8 bits, so 8 bits you can code octal numbers. Okay, all right. So now this is the IPv4 address. Now similarly we have IPv6 numbers, because we found that with 32 bits we can have only 2 raised to 32 addresses, right? This is very small number. So the next generation of IP that we use is IPv6, where we use, instead of 32 we have 4 times of that number of bits. Okay, please find out detailed difference between IPv4 and IPv6. This exercise to you, I will ask few questions in this one, on this one. Okay, okay, now so so once IP packet comes here, what does router do? The router looks at the IP address, then send packets to router closer to destination. How does it find out whether, suppose whether to send the packet on this route or the route? As we mentioned, that there is already information that it has learned about the network using some routing protocol like OSPF, etc., etc., which fills in this kind of table, routing table. So the network continuously learn about the routes and updates its own routing table. Okay, and that table is used to take local decision. Like traffic policeman on the way will have some parchi or some paper on which will say somebody is going to Delhi, then take left side of route rather than right side of the route or right side of the road. Okay. So that kind of local decision happens all throughout when you travel from Mandi to Delhi. At each point, traffic police guy decides where to send you to. Okay, all right. Same thing happens on internet. So IP address, it means must have some structure. There must be some semantics inside, right? So IP address of, for example, Mandi is different from IP address of Chicago. Okay. All right. And based on that, routing decisions happen. Okay. So summary so far is that key application send and receive data in packets over the internet. That's unreliable. And packets are forwarded hop by hop based on final destination address. Okay. Now each hop could be a different type of link. Okay, for example, when your mother's laddu packet is traveling, person may go on cycle, or maybe then packet may travel over truck, then travel over say bike, then travel over flight, and so on and so forth, or maybe a sea ship or whatever. Okay, so this, and then when IP packet comes, okay, okay, then it is enveloped into something else which is a larger side packet corresponding to that link. So link may be, for example, Ethernet. Then this IP packet will go inside Ethernet frame or Ethernet packet, and that will traverse across the link, and other node will receive it and then take this out and take this IP out and then send it to the next link over, and put this packet that's received over another frame or packet corresponding to that link. If it is a Wi-Fi, it could be different outer packet. So this is the technology that we use. Okay. So internet cannot be trusted because it does not promise packet delivery in order. It does not promise that packets will be delivered quickly or in on time. Okay. Now question now here can be raised. It does not give any guarantee that it will take few milliseconds, microsecond or nanosecond or whatever, right? Then if you are doing, for example, using it in real-time applications, you are controlling the missile firing, from some distance, then how do you, and that requires, missile firing requires a precision of nanoseconds, then how do you control that? So the question you can ask yourself and try to answer, how to use the internet in real-time application. Real-time is that mission critical application, you can say. Like hospital, some surgeon may be in New York doing surgery in Delhi. How can it be done when internet does not provide any guarantee on time, or it does not provide any real-time guarantee of delivery of packets, and on top of that, it does not promise that even packets will be delivered at all. So it does only best effort attempt. So now the question you can say is that how do you then send packets reliably over the internet? Okay. Okay, so of course networks are complex. It has hosts, routers, links of various types, right? It could be copper, it could be fiber, it could be air, whatever, right? And correspondingly, protocols at link layer will be different. For example, when your laddu packet, this is actually the content. It goes over cycle, the guy will put it in a jhola, or what do you call that, a small paper bag, or cloth bag. Okay, when this at at some place this packet is removed from this jhola or cloth bag, and laddu packet comes out, and next link is over truck, then it will be put inside a cardboard box, and where source address will be this and destination will be on this bigger cardboard box. Source address is this node and destination is the next node at the other end of the link, and so on. Similarly packets travel this way. Okay, so there can be links of various types: Ethernet, fiber, whatever, copper, air, okay, or cables of different types, and different applications run at the end. There are good number of protocols, hardware, software. So networks in general are complex, and we have to organize in such a way that it reduces complexity, easy to design and develop, and increases the modularity. When we say modularity, it means that a whole functionality is put into different modules such that if one module changes it, and if the interfaces remain the same, then it does not impact overall functionality of the network, right? Okay, and for that all we do is that something that we studied is layering for different layers, and we'll come back to this little later. Okay, so this again same thing. Communication is always, see, when we say packet traversal is one way, right? So from your machine packets go to destination or server, and server sends it. Now the packets in general most likely take the same route, but that's not the necessary condition. Okay, so packets may go through different route to destination, but the return path could be very different. Okay, so communication in both direction is called bidirectional communication. Okay, all right, and then most of the applications require communication to be reliable, but internet is not reliable. Is unformatted pipe, as we have seen, leaky pipe, then we'll have to provide reliability using something. Okay, one such method of reliability, providing reliability, is TCP protocol, which we'll study in detail little later, but this discussion will give you a very high level view of it. Okay, all right. So this is, in what we do here is that we, both source and destination, say A and B, must have some understanding. Okay, okay, and that we call it a logical connection. Now for example, A and B, when A says that I am setting connection with you, B will reserve some buffer for receiving packets, receiving data. Must have some understanding between the two, right? And first it must accept connection from A. For example, B is a server in some defense force, and somebody from, say, Hamas is trying to log into this using TCP, or any terrorist organization, then this may refuse a connection. Okay, all right. So now we have this byte stream model, which we'll discuss now. So first thing is connection setup. It means that there's understanding between A and B is ready to receive data from A, and A is ready to receive data from B. Okay, and then there is a stream of bytes will be sent. Now you note that your application, like when you are streaming data for Netflix, for example, is streaming data is continuous stream of data that you are receiving, right? But so your app will send a stream of data, and so for logically you will see this sequence of bits that are going. Okay, and similarly and it's being received, but actually, and similarly this B will send a stream of bytes or bits, and then actually it's these bits in practice, in actual life, will be converted or will be sent over IP. Okay, this IP packet with this header and IP packet. So this stream of bits will be filled in IP packets, multiple IP packets, and then these packets will traverse to other end, and other end will recreate a stream of byte. Okay, and once this communication is over, then A can request please close the connection, and B will accept it, and that's all, right? So this is normally what we do in TCP. And then, for example, HTTP, same thing happens, right? Connection setup request, and connection is accepted, and then data is sent, stream of data like get slash http slash 1.1 index.html, and then a stream of bytes are sent from this server to client, and after sometimes close connection request grown from client, and its server accepts it, and that's all. Okay, okay. So but in practice, all these things data goes over IP. Now logically you can see application can see they are sending just stream of bytes, but in fact these are packed inside IP packet. Okay, and IP packet goes to other end and receive, and then from this IP packet data is taken out, and again same stream is created. Now this may happen if you don't need any reliability. Of course there will be something in between called UDP, which is simplest protocol uh, that does not that's used when you don't need any reliability. However, if you need reliability, if you want that even one packet loss is there or few bits in a packet are missing, you may want reliability in the sense that you may ask source to resend that. Okay, then you need TCP. Okay, this is what we discussed. So we need TCP. So now your application stream will go over TCP, and TCP will go over IP, and then this will go over Ethernet or whatever. But when let's not go to lower level now, and then IP packet received from that IP packet. So IP packet is this one, so IP header. Then this is TCP packet. So TCP packet again will have a header and data. So that from that this data is taken out, and then it's given to the application. Okay. So TCP's job is to make sure all data is delivered correctly and deliver data to the application in right order. Okay, and this is how do you do it? How does it do it? What could be the way? Let's assume your mother sent, instead of one laddu packet, she sent 10 packets to you. I mean, maybe different sweets or whatever. And then how will you come to know, or she come to know, that something is missing? In between, courier has not delivered one packet. How will she know? Anyone? How will she know which particular packet is missed? For example, the number first packet is laddu, second packet is barfi, third packet may be cake, fourth packet may be something else, and so on. And one of them is missing. How will she know which one of the packet is missing?
So we can tell what all packets we received.
Yeah, you can tell what all packets you received, right? Yeah, so very good. So simple is that she will number them and create a small table. That first packet is laddu, second is whatever, third is some, and then she will ask you, or when you look at the packet number, say 3 is missing, then you'll inform your mother packet number 3 is missing. Then you say, okay, all right, this particular packet is missing, I will resend it. Same thing happens here in TCP. When we send packet, we add a sequence number. But how we put this sequence number, that will study, right? Okay, it's not necessarily for every packet, but some sequence number we use. Okay, simple is that packet, each packet wise, but of course, I mean, we use slightly more complex method. So we sequence number we use, and when we see something missing, then we can request reorder. Sender to, because sender will keep that until it receives acknowledgement that everything is fine. When you tell your mother that I have received all 5 packets, then she will stop. If she is something in buffer, she will throw that out. Okay, similarly sender will keep all the information in buffer, and when acknowledgement comes, then that information is thrown out. Okay, all right. So there is a concept of sequence number and acknowledgement. These are two, and we use this in real life also, right? All right. Okay, and we have seen that packets are encapsulated at different layers. The application is sending data here. Application must be hidden from all the difficulties of life, of internet, right? Your application will see just nothing but stream of data bits that is to be sent. That's it. Just a minute. Okay. Okay. All right. So now, the application creates a data like this. Okay. Now this data goes to next level, that is TCP. TCP will put this inside its own header, in own packet, right? So it's something like this. Okay, this something like this. Okay, so this is the header it has created. Now here, there will be some information in the header. It's not IP address node. For example, there may be multiple applications that are using that are using this connection. So now we can have some kind of port number here and so on and so forth in this header, right? So we can have some information that now here on top it's HTTP application that's using it. So we can write here instead of HTTP some number, such that when receiver receives it, know where to deliver it to. Okay, so it will have source port number and also destination port number. Okay, all right. So now it says that deliver it to HTTP server instead of FTP server or some other server, right? So there is some port number or whatever, and now this packet has got to come to IP layer. Now IP will put this TCP packet inside its own envelope or box or packet, and then add its own header. Okay, now it will have a header which will say now deliver it to some destination IP address, and this header here will say that deliver it to particular port or application. Okay, all right. And now next level is that now this packet is created. Note that this IP level communication will happen all throughout the network. Only these two things, TCP or UDP, will happen only at endpoints, right? So now this packet has to go over local link, like your machine here is connected over, say, Ethernet to next server, next router. So now your packet has to go inside Ethernet frame. And what will be destination address here? Destination address will be endpoints of that link, where another router is connected. Okay, all right. In this way, when this packet Ethernet frame is received here, it will take this IP packet out and look at the IP address, and they take decision where to send it to. One of the links will be selected, and before sending it, it will again put that IP packet into that link's packet. Like second link, for example, is instead of Ethernet, second link is Sonnet. It will put inside this IP packet inside Sonnet frame. and here destination will be end of the link address, right? Whatever is connected there. Okay, this is how the packet travels. Okay, all right. So yeah, so this is it. Ethernet, this Ethernet packet formed at the link level. This between one link to another link. So this is Ethernet. So this go into Ethernet box, reaches to other end. Another end will put this into, select the link and put this into another packet and so on. Okay, all right. So this how this packet reaches other end. Okay, actually it's IP packet that travels, and link layer packet is removed at the end at each router, and new packet is created. Like mother's laddu box, every link between say from Delhi to Chandigarh, it will go over say truck, then it's a one box. From Chandigarh to Mandi, it's another kind of box, and so on and so forth, right? Okay, so this is how your HTTP packet request travels. At the other end, Ethernet packet is outer packet is removed after some checks, an IP packet is taken out. This is the IP packet. Now some checks are done, and then TCP part is taken out. This is TCP part. Again some checks are done, and bits or bytes are delivered to application. So this is how it happens, right? Okay, so although, but for user it will look just simply communication of the data. Over internet, that's unreliable. Any question? So I have used this animation and pictures to give you some idea about what is the use of layering and how does it happen, because otherwise it's very hard to understand. If you read the textbook, it's until you focus a lot, it's the whole idea doesn't come out very well. Okay, now you can understand what is the role of link layer. Link layer is something that local router has to send it to the next router. Okay, from your mother's home, is only somebody will come on cycle to collect. So that cycle and the road up to that point, courier office point, is the link. The road is the link, and link on link only cycle can go. So this provides a link level technology. Okay, now let's come back to Alice. Alice goes to a cafe, or you go to airport, and then you want to connect. So Alice goes to cafe and she wants to do Google search. Okay, she opens her laptop. What will happen next? And assume that she has come to Delhi from New York. What will happen next? You do every day. So you please tell me what will happen next. Quick, we have just 10 minutes left out. When you go to a new place, a coffee shop, and you want to do internet connection, what do?
Sir, we'll look for a Wi-Fi connection.
Excellent. Okay, so she is here in coffee shop. She wants to join a wireless network. Now she might have come to this cafe earlier, so her laptop will shout, hey, does any wireless network exist? So there are always communication that your Wi-Fi, your mobile phone, if your Wi-Fi is on, it will communicate, send signals out. Okay, is there a network? Okay, and there is of course Wi-Fi point. Okay, a Wi-Fi terminal equipment, a router, and that will also emit. What will it say? Okay, I am here, network Y, join me. So the communication may happen both ways. Okay, if you have gone to that shop just a day earlier, or at least has been there before, then it's already communication has happened, and you know, you simply join. When you simply walk into your house and your Wi-Fi is on, you don't need to do too many things, right? It's automatically logs into that. Similarly, it can happen, right? So either match up, then the join. Otherwise, you use a password to log in into the Wi-Fi network. These are only two things, right? It means that password is already there, stored into your laptop, and then it matches with password in Wi-Fi point, and connection happens. So what will happen next? Let's assume that this connection to Wi-Fi happen. Now the note that Wi-Fi is all signal on air or can be read by anybody. The next thing happens is that she doesn't want her communication to be seen by anybody. So now only solution that we have in life is cryptography, and that you have studied in detail. Now she is done a lot of browsing she has to do. So what kind of protocol will be used? Symmetric or asymmetric? I'm answering you here. You just need to repeat. Lot of communication has to happen. If she may want to transfer a file or read a big, download something, a movie or whatever. We have spent more than 10 hours on cryptography, right? There are two kinds of protocols: asymmetric key encryption like RSA and symmetric key encryption. Which one she will use for long session? Anyone, try at least.
It's faster than like asymmetric, so
Yeah,
probably
very good. She has to use symmetric key. It could be any of these, right? Depending on the protocol. One of the symmetric key encryptions. And how does then keys exchange? Obviously symmetric encryption requires key, shared key, right? Symmetric shared key. How does it happen? Now does it based on the password? Password is used as key, or this laptop will generate a random number, pseudo random number, and use asymmetric key encryption like RSA or something to send the key to other end, or it can use Diffie-Hellman to generate a shared symmetric key. Okay, this question you need to figure out by yourself. Okay, of course this is symmetric encryption for data transfer, and how keys exchange, that you'll have to figure it out. Okay, fine. So that now connection is set, and then what is the next thing that you need? Now she has come from New York and is come for the first time. She cannot use the IP address that she was using in New York. So she will say, okay, please give me IP address, because only then I can send packet. This becomes my address and I can receive packets on that address, right? So this is IP address. She will need IP address. The minimum she needs this, right? What else she will need? She will need, if she wants to do google.com, now her laptop will require google.com to convert into IP address, because IP packets travel over, uses only IP destination address, right? So there must be some domain name server. that will convert her URL into IP address. She needs address of that URL domain name server, or she needs to know how to reach there. Okay, what else she needs? She is inside a local area network, and there is always a router that connects to the external world, and she is sitting here, so she needs to find out what is that router that connects to the external world. So she needs minimum these three things, and who can provide this? Okay, there's the next thing. There is a server called DSCP server. Okay, now this DSCP server is usually in the same local area network, can supply these three things to her. Okay, so if this DSCP server responds back to her, okay, your IP address is this, router's address is something, and so on. Okay, so the configuration include IP address, your IP address, which is temporarily given to her, address of the gateway router, and then address of domain name server. These three things are provided as part of DHCP response. Okay, how does it happen? We'll study when we study layer 2. Okay, now she needs to know where is google.com. Okay, all right, what is the address of google.com? And then this is transmitted over UDP protocol. Okay, and then the DNS resolver might not be in the network, right? Okay, so this DNS server, there's a possibility inside the network or it may not be inside the network. If it is not inside the network, then her request will go through the gateway, this gateway router, whose address she has got through DSCP query. Okay, and through that her request will go to that particular DNS server that has answer of her query, google.com, where google.com exists. There's a very possibility that there may be a resolver very close to her, but there is also possibility that it can be very far. For example, I create my website ravimittal.com. I just create it today and it's not known to anybody. Okay, then this query has to go to many level up in DNS server hierarchy until this gets resolved, because sometimes in this hierarchy, somewhere on the top of hierarchy, this information is available, and that domain name server responds back to her that corresponding to google.com, this is a IP address. So IP address of google.com is this, that will be sent to her, and she now has google.com's IP address, which comes from very remote server, and she receives Google's IP address. Okay, they said some problem with animation, so she received this. Now she has that address, and now she can communicate with that google.com server over TCP. And she first step is that she wants to do communication over TCP. Okay, and in order to do TCP, we know is that connection oriented protocol. So she does SYN request, which we'll study later, and then connection is set up. When SYN is responded back, connection is set up. Okay, so SYN comes to her and TCP connection is set up. Okay, basically both agree, and then now connection is to be set up, right? And what is that? She has to create a secure channel. How does it, how will it happen? Okay, so she will use TLS instead of just HTTP. She will use HTTPS. So now the question is that what kind of communication both will have for security? Of course, is again it will be symmetric key and key exchange has to happen, and that will happen over asymmetric key encryption, right? So you can use, for example, RSA or, for example, Diffie-Hellman. You'll have to see how TCP works or TLS works, or HTTPS works. We'll study at the end. Okay, one of the protocols are used for example, from our knowledge, we can use one of the asymmetric key protocol for key exchanges, and the asymmetric key encryption can happen between the two. Okay, all right. So this is how it works. And of course, before that, how does she know that she is communicating with actual actual google.com? It means now this guy has to send his public key certificate or digital certificate. Okay, so this is how they, oh, okay. Okay, so now once so both digital certificate is sent by server google.com to Alice. She verifies this by sending a small piece of data, and this guy responds back. Then she is sure that she's communicating actually with google.com. Once that happens, she can now send the data over secure channel. Okay, all right. So that's all. So now when we have this kind of layered structure, okay, and what we can see is that in layered structure we have to provide security at each level: physical layer, data link layer, network layer, and so on. And that's what we'll study in the next few lectures. Okay, all right. Okay, thank you.